On our notes, we're learning about two special right triangles. And probably the most common mistake that happens after I teach special right triangles is that people want to treat every right triangle on Earth as if they're special right triangles, and they're not. Okay? You must only use these properties for special right triangles. How do you know that they're special? Because, guys, let's get focused, please. There should be. There's only two kinds of special right triangles. Caitlin, the question that you asked was, how do I know whether they're special? They're special because of their angle measures. Notice the names of the two triangles that we're dealing with today. There's a 45-45-90, and there's a 30-60-90. So what I hope that you would observe is that the 45, 45, and 90 are referring to the angles of the triangle. So let us consider what that triangle might look like. And since those two angles are 45 degrees, what vocabulary word might I use to describe that triangle? It is isosceles. So I know this is congruent to this, which means if this side has a value of x, then so does this side. This hypotenuse can now be solved for using Pythagorean theorem. We can solve for that hypotenuse in terms of x. Here's what it would look like. We'd have x squared plus x squared equals hypotenuse squared. We saw an example that kind of started off like this earlier today. X squared plus x squared, realize, is 2x squared. And if I'm trying to figure out what h is, the next step in solving for h would be to take the square root of both sides. So I would have that h equals, look at that radical. Can I simplify the 2 part of that radical? Can I simplify the square root of 2? No, it's a prime number, doesn't simplify. How about the square root of x squared? What is the square root of x squared? It's just x. So what we found here is that the hypotenuse is x radical 2. Put another way, you might want to add in your notes that the hypotenuse equals the leg times radical 2. And what this gives us is a nice, pretty shortcut for finding the length of a hypotenuse when I know the leg in a 45, 45, 90. Or letting me find the leg when I already know the hypotenuse in a 45, 45, 90. So, looking at problem 1, notice I have a 45, 45, 90. I know what the leg is. I'm asked, what is the hypotenuse? So, what is it? It's 8 radical 2. That's it. So,
like 3 of these easy problems.
I'm sorry?
Do like 3 of these problems because they're so easy.
Yeah. So in part B, notice we're going in the opposite direction. I know what the hypotenuse is. I'm trying to find the leg. No? Well, it's fine. Good.
Oh.
Think about it this way. If I know the hypotenuse and I'm trying to find the leg, does it make sense that instead of multiplying by 2, I would do the opposite of that? I divide by 2. And if I take this 5 radical 2 and divide by radical 2, does it make sense the radical 2's cancel out? Okay, a little bit, what? Oh, no, it doesn't have a radical in part C. Wonderful. She's looking ahead and she noticed, oh, no, there's no radical to cancel out. But you at least realized that I need to take this 10 and divide it by radical 2. Uh-oh. Why did someone say uh-oh?
Uh-oh.
Because math just makes you go uh-oh. What I would hope you're uh-ohing about is that you're not allowed to have a radical in the denominator. That's one of those rules of radicals. So the way that you get it out of the denominator is to multiply top and bottom by that radical 2. Well, guys, whoa. What cancels out? Which ones? The ones on the bottom, right? That's the whole idea, is you're trying to get rid of having a radical on the bottom. Across the top, though, let's go step by step. Across the top, I multiply straight across, I get 10 radical 2. And as you wonderfully observed, the radical cancels out, and I just have 2 on the bottom. Because square root of 2 times square root of 2 is square root of 4, which is 2. Oh, if I'm hearing questions, I definitely want to talk about them, but I need to hear them in some kind of an organized manner. Maddie?
Can you go through it much slower?
You got it. Okay, so this stuff, this is where I start, the 10 over radical 2, because I know what the hypotenuse is, and I'm trying to find the leg, and my property says that the hypotenuse is leg times radical 2, so I need to divide by radical 2. With me so far? Okay, but I'm not allowed to have a radical on the bottom. So the way that you get rid of that is to multiply top and bottom by that radical. Realize why we're allowed to do this. What am I multiplying by here? I'm multiplying by 1. I can multiply by 1 until the cows come home. I'm not changing anything. I'm just making it prettier to look at. Okay? So, understand why I'm multiplying by radical 2 over radical 2. Okay, across the top, this is outside, this is inside. They don't play nicely together, so it's just 10 radical 2. And then on the bottom, square root of 2 times square root of 2 is the square root of 4. By now, you know that the square root of 4 is 2.
So that's your answer.
But can I clean this up any further?
Yes.
What do I get, Benjamin?
You get 5 radical 2.
Your answer is 5 radical 2.
Okay, I see how you did that.
Beautiful. Music to my ears. And there's a your turn for this. Please work through that. 84% of us got the correct answer. Correct answer is B.
Alright, so
Of course I'll explain this to you. Waiting. In your notes, you have that the hypotenuse equals the leg times radical 2. In this problem, you're told that the leg is 5 radical 3. So you take that 5 radical 3, you multiply by radical 2, realize the only thing that you can simplify here is the 2 radicals being multiplied together. Please realize you can only simplify together what's inside or what's outside. You can't simplify what's outside with what's inside. They don't play nicely together.
please
Outside
and
and
say
say that one more time.
Okay.
Like,
All right, let me make sure that we're all talking the same language. The 3 and the 2 are what I'm referring to as inside. Notice that they are inside the radical.
alright.
The 5 is not. Inside and outside don't play nicely together.
Okay.
Only things I can multiply together are this 3 and 2, and that's why I get 5 times the square root of 6.
Yeah, that was a lot better.
Wonderful. It's what I live for.
Outside can go to inside, the inside can go to outside.
All right, moving on. Oh, there's so much. All right, so in problem 3, you see that we're taking this concept and now bringing it into a real-world situation. I have a square, ladies. I have a square with 250-foot-long sides. And I'm trying to find the distance from one corner of the courtyard to the other. So what I would hope that you're realizing is that when I cut this square across the diagonal, what I'm ending up with is 45, 45, 90 triangles. Excellent question. Remember that a square has all 90-degree angles. Remember that a square, from 2 chapters ago, is also a rhombus, the diagonals of which bisect each of the angles. See how all of this comes together?
This is why I don't like that.
Sorry. All right. So, in this problem, what we're finding is the hypotenuse of this 45, 45, 90. And once again, in your notes, you have that the hypotenuse is leg radical 2. Conveniently, it's asking you to round your answer to the nearest tenth. So what you're typing into your calculator is 250 times the square root of 2. And when you round to the nearest tenth, we have 353.6 feet. Yes, ma'am. Oh, be careful. Please understand. I'm not multiplying 2 times 250 in my efforts to simplify. I'm taking the square root of 2 and multiplying it by 250.
Oh,
Okay.
Two.
1 point, approximately. That's what your calculator's for, guys. Square root of 2.
it's like 1.4.
Okay, that's what I said. 1 point. And then multiply that times. Coming up with the properties of it would be a little bit funkier. And that's why I'm not doing that. I'm just giving you the properties. Look, they're right there. Woo! Okay?
Yeah.
I do, however, want to just give you a glimpse of where this 30, 60, 90 triangle is coming from. It comes from an equilateral triangle. Remember that in an equilateral triangle, all of its angles are 60 degrees. So in this equilateral triangle, if I drop an altitude, where of course that's forming a 90-degree angle, now you see our 30, 60, 90 triangle. Where if this is x, the hypotenuse of it is twice as long, and the long leg is x radical 3. Now I'm sensing some stress, oh goodness, how am I going to memorize this? You don't have to memorize it. It's on the reference sheet. Okay? Right there. On the reference sheet. You just have to remember how to use it. Oh my goodness. All right, so in problem 4, let's talk about how to use this, gentlemen. Stay focused. Right, so in problem 4, since a 30, 60, 90 triangle is a little bit more involved than a 45, 45, 90 triangle, and here's what I mean by that. In 45, 45, 90, there's just leg and hypotenuse, and that's it. In a 30, 60, 90, realize there's a short leg, a long leg, and a hypotenuse. So realize in problem 4 what they're giving you and what they're asking you for. So what are they giving you? What is that 15? Is it the short leg, the long leg, or the hypotenuse? It is the long leg. What are you being asked for? The short leg. Okay, so according to this, which is exactly what it looks like on the reference sheet, I'm trying to figure out what x is.
7.5.
Oh, no. Notice up here the relationship between the long leg and the short leg. The long leg is the short leg times radical 3. I need to go backwards and find the short leg, so I would hope that you realize we're taking that 15 and dividing it by radical 3.
No, I don't.
Yeah, that's where it is.
Why would I do that when I just
Okay.
do?
Up here, notice that the long leg, this 15, is the short leg times radical 3.
All right.
Okay, here's another way to look at it. This 15, do you see, is x radical 3.
Yeah.
what do I want to find? I want to find x. How would I solve for x? By dividing both sides by radical 3. Does that help?
Yeah.
Wonderful. That's what I live for. Ladies, that's not what I live for. All right, here. What do I do with this? Because I have that icky radical on the bottom. Multiply top and bottom by that radical 3. Straight across the top, I have 15 radical 3. Across the bottom, I have just 3. Good. Because square root of 3 times square root of 3 is square root of 9. And square root of 9 is 3. Can I do anything with this?
Yes.
Yes.
It'd be 5.
It'd be 5 radical 3. Beautiful. Yes, Sarah.
Will there ever be like a test where you're trying to get this on scale?
Wonderful question. I love it.
Clouse, you got this.
You got this?
Because like 2 lessons ago, we learned angles, like that's a small angle, it's the smallest leg. It's like straight through.
So what I'm hoping he's getting to is that, Sarah, the short leg is going to be opposite the 30, and the long leg would be opposite the 60. Okay. Good on this screen. Okay. This one, that's never it.
Oh, so we're running out of time. Are you sure?
Actually, I don't want this one to be a your turn. I want to go over it with you. Guys, if we don't have time for a daily quiz, then we don't have time for a daily quiz. But I want to get through enough of my lesson so that you have enough to work with in your assignment. Okay, so in this problem, first of all, do you see that we're dealing with the exact same situation as the last problem? I know what my long leg is, and I got to find my short leg. This time I'm also being asked for the hypotenuse. I would hope that you'd realize I'm going to start this problem exactly the same way we started the last problem. I need to take that long leg and divide it by radical 3 in order to find D, my short leg. Are you kind of getting an inkling that this one isn't going to work out as pretty as the last one did? The reason why the last one worked out a little bit pretty is because I realized that we ended up taking that long leg, that 15, and dividing it by 3. This time, look at what my long leg is. That's 5. Am I going to have much luck dividing it by 3 and ending up with something pretty? No. Okay? But we're going to start the process the same way by getting that radical out of the denominator. Straight across the top, once again, I have 5 radical 3. Straight across the bottom, it's just 3. And I can't do a darn thing with it. That's D. Now this problem is... Taylor?
Where's 1 3? Wait, which is the end product? The top one or the bottom one? Okay, got it. I thought it was the top one.
All right, this problem is also asking us to find the hypotenuse. In a 30, 60, 90 triangle, what do I know about the hypotenuse? It's 2 times the short leg. We just found this short leg. So in order to find F, I'm going to take 2 over 1 times 5 radical 3 over 3. It's not pretty, but it is our answer. 10 radical 3 over 3. We have from the script. Still getting. Remember, the only things I'm allowed to multiply together are if I have 2 things that are outside or 2 things that are inside. Notice what I have outside, the 2 times 5. There's my 10. Nothing else can simplify here.